Good evening, sir. Yes, sir. Just a second. Good evening, everyone.
Good evening, ma'am.
Evening, ma'am.
Good evening. Good evening, everyone.
Good evening.
Yes, good evening, Vivek, sir. So, friends, today I'll talk about the next test, which is the ANOVA and one-way ANOVA. And if time permits, we'll go for the correlation and regression both, right? So, just a minute. Okay. So, I'll share my screen first. Give me a second. Okay. I think I shared my screen. Is it visible or not?
Yes, ma'am.
Yes, ma'am.
Fine. Okay. So, friends, we'll talk about today the concept of ANOVA first, and then we'll see how we can use Excel for performing ANOVA, right? So, here, when I say ANOVA, I think everyone knows, and ANOVA stands for, or is analysis of
Variance.
variance, is ANOVA, right? Now, when I say ANOVA, ANOVA is nothing but it is extended form of independent samples t-test, right? So, it is extended form of independent samples t-test. Meaning is that it will be used for anyone? Comparison of mean,
Means.
right? So it will compare the mean of numeric variable, right? But when I say it is used for the comparison of finding the significant mean difference, question comes when t-test is already available to check this thing or to compare the mean. In that case, what is the use of this ANOVA? Why we are using the two different tests for performing or for getting the same thing? So the answer is very simple. Yesterday I said to compare the two groups or two samples, we are using the t independent samples t-test. But here, when you are having the more than two unrelated groups, in that case, T cannot perform to get the significant mean difference simultaneously in all the groups, right? If you want to compare the groups of, if you want to compare the means of all the groups together, in that case, it is not a capacity of T to do so. So for the purpose, we are having ANOVA with us, right? So ANOVA can help you compare the means of or mean of numeric variable in more than two groups or samples of IV, independent variable. Is it okay? Clear?
Yes, ma'am.
So meaning is, if I ask you what is the variable requirement, can anyone tell me? So I think this I'll take afterwards. Before, just a minute. We'll talk about firstly the types. So I think everyone knows there is one-way ANOVA and two-way ANOVA. These are the two varieties in ANOVA available, right? One-way and two-way. So I'll talk about firstly the variable requirement for the one-way, right? So here we need to have one dv, that is numeric variable or continuous variable, and we need to have one iv, which is categorical variable with more than two groups. Clear? Done, everyone?
Yes, ma'am.
Then we'll see variable requirement for two-way ANOVA. Here we will be one dependent variable, which will be numeric or categorical, and we'll be having two IVs. That is categorical variable. So this is the variable requirement of the two-way ANOVA, right? So if suppose I am teaching in, or maybe in our college, suppose there are 5 sections, right? And we want to compare the marks of all the sections together. In that case, we'll go for one-way ANOVA because I am comparing the marks of the students of 5 different sections. So that way I'll be having the marks variable, I'll be having the section variable, there I'm having the 5 different groups, right? If I compare the marks of 5 sections on the basis of gender, that means I'm having total 3 variables: marks, the section, and the gender. That is the example of two-way ANOVA. Clear to everyone?
Yes, ma'am.
Okay. What about others? It's clear to all?
Yes, ma'am.
Yeah. So means this is the very basic thing about the ANOVA when I talked about. So when I say ANOVA stands for analysis of variance, that means we are interested to compare the whether there is a variance in the mean in the different group is there or not, or in all the group mean variance is same. So this is the meaning of this ANOVA. Now we'll see one by one and we'll see how to perform ANOVA using Excel. So I think with the example, I'll explain you how to formulate your hypothesis, right? Come to your one-way ANOVA sheet. I hope you can see. Here we are having the example available with us. So I think rather than explaining me, I want you, when you are looking at the sheet, when you are looking at this data, can any one of you will tell me what is the variables available in this particular sheet? Yes.
Ma'am, the strength of tapes and the tape supplier.
Yes, very correct, Harpreet ma'am. So we are having the strength of the tape, which will be your numeric variable. So these are the strengths which are mentioned here, right? And that way we can say this is a numeric variable we are having. We want to compare the mean tape strength, right? And we are having the next variable, which is the categorical variable, that is the type of supplier, right? Supplier 1, 2, and 3. Getting me? So this way we are having the two variables. So this is the variable requirement for the one-way ANOVA. Only one categorical variable with more than two groups, so that you can find. And if I want to compare the mean strength of the tapes in all the three groups together, means if I want to find only the tape strength difference in the two groups, supplier 1 and supplier 2, it is like we will not go for ANOVA, we will go for only the t-test. But if I want to compare all the groups together, more than two groups together, in that case, we'll go for the ANOVA, right? So firstly, I'll write my hypothesis here. Anyone who can tell me the hypothesis?
There is no significant difference between the tape strength of all three groups.
Very correct. Done? Done?
Yes, ma'am.
Fine. So now, if I want to test this hypothesis at 5% level of significance, according to the data, means according to the ANOVA, one-way ANOVA requirement, we are having the two variables available with us, and we have formulated the hypothesis. We have set the level of significance also. Now I'll go to the data tab. Then I'll go to the data analysis tab, and here I'll go up. You can find ANOVA single factor is listed here. Single factor meaning is one factor or one variable, one independent variable. Factor meaning is independent variable, right? You need to select this option. I hope you have seen. May I click on OK?
Yes, ma'am.
Yeah. Here it is asking you to give the range of your data, right? So I am selecting the entire data points here, including the labels of the columns. So the range is A2 to C32. Done?
Yes, ma'am.
Then it is asking you your data is grouped by column or row. So I think it is quite visible. Data is in the column form. First supply data, second supply data, and third supply data. So data is in the column form or grouped in the column. So we'll go with the by default option. If your data will be in a row, in that case, you need to select the rows, right? Labels are selected. I need to check this box. By default, level of significance or alpha value is 5%. This is already set here. If you want to change, you can come to the box and make changes. Output range, I'm selecting the first option. And then coming to this box. And then selecting the blank cell where I want to get the output. So this is all you need to do to get the output. Done?
Yes, ma'am.
Yes, ma'am.
Okay, you click on the OK button. You will be getting the output of the ANOVA. Now we'll interpret this output. Everyone have got this? May I start explaining the interpretation part?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yeah. Fine. You can find here. We are having the summary table first, which is telling you the strength. Firstly, for the three suppliers, we are having the 30 samples of the tapes from each supplier. This is the sum of the strength of the tapes. This is the average strength. This is the variance in the strength of the tapes from the three suppliers. This is the meaning of this table. Coming to the next table or the main table, which is for the ANOVA. So the ANOVA table is telling you, means you need to see it is those who are good in statistics part or maybe studied the statistics manually. They know this thing. The final ANOVA table is generally manually also created like this on. There we will be having the source of variation, then sum of square, degree of freedom, and the mean sum of square, F value. Generally, your table is still coming here. Till this point, you are making your table when you're talking about the manual calculations, right? So, source of variation meaning is that between the groups and within the groups. Between the groups meaning is here because you are having only the columns available, right? Or maybe row wise also it will be. So we will be having only the three groups available. So in the three groups, what is the sum of square coming? This is this. Within the group is meaning is that in the same group, right? Means what is the variation coming in the same group? If I'll compare all the tape strengths with the mean of this tape, mean of this particular group tape strength, right? Means I'll take the mean of this particular column, and from that mean, if I will compare all the figures, so that way you will get this within groups, right? So you need to do for all the three groups, and then you will take the average of that. So this sum of square will come for us. Then degrees of freedom. So we are having total three groups. So n minus 1, that is 3 minus 1. This will be the 2, right? And finally, the within the groups degrees of freedom. So this is meaning is what? Total observation. So as you can see, we are having 30 per what I can say group or sample. So that way we are having total 90 observations. So this is n minus k. N minus k meaning is total number of observations minus number of groups. So 90 minus 3 groups, so that is 87 will be the degrees of freedom. Then mean sum of square comes like this. Sum of square will be divided by its respective degrees of freedom. That is 8.84956 divided by 2 will give you this. Similarly for this also. So you can divide this SS by this DF. You will get this MS. And then for getting the F value, you need to divide the between the group mean sum of square by its within the group mean sum of square, means 4.42478 divided by 0.3355. So you will get this F value, right?
Yes, ma'am.
Done. So after that, the P value is calculated by software for us, and this is the table value of the F. So you can use the thumb rule. I think we discussed yesterday. So that way you can see if I'll go with this F stat, this is your F state value. So if I'll compare this with this critical value, so I can write it here, F stat is greater than F critical. Yes. 13.185 is greater than 3.103. Yes. So this is a case we are going to reject null hypothesis. And we have made the null hypothesis here. So you can read the hypothesis. This is we are rejecting. That means we are telling this thing that there is a significant difference in the mean tape strength on the basis of the suppliers. Means from the different suppliers, if you are taking the tape, so the mean the tape strength will be different. This is the meaning, right? Using the P value if you want to interpret. So you can see your P is less than 0.05. That means again it is telling you do not accept or reject your null hypothesis. So either this or this, any of the thumb rule you can use to come to the conclusion of the acceptance or rejection of the hypothesis. Is it done? Clear?
Yes, ma'am.
Okay, no doubt to anyone? Friends, done? Note it down, right?
Yes, ma'am.
Fine. So the next sheet is for your practice purpose. This is the practice sheet of the one-way ANOVA. This you can use for your purpose. You can read the problem using the data. You can solve the problem, right? I'll come to the next sheet, which is starting here with the two-way ANOVA. So practice sheet of WR means with replication case. I'll explain you. With WR meaning is with replication. So I'll explain you what is with application here. So in two-way ANOVA, there are two varieties, with replication and without replication. Usually the people which are collecting the data using the questionnaire, we are talking about the with replication case. In those people's case, this is the with replication case. But if you are doing any experimental study, generally in experimental study, this is the without replication case we are talking about, right? So you can make a difference in these two by understanding this concept. With replication, because you are collecting the data. Suppose I said On the basis of gender and on the basis of the section, I'm collecting the data of the marks. So it is quite obvious in a particular class there will be more than means 2. Quite obvious means we will be having almost 40, 50 students or 60 students in a class. So there will be multiple students who are belonging to the male category, multiple students belonging to the female category. So there is a replication in the category inside, right? That is a replication case. So generally first hand data is based on this. But when we are going for the experimental kind of studies, so that means you are deciding in a particular farm, you are sowing something and like that. So that way, which type of fertilizers you are using, what is the quality of, or what is the quantity of water you are giving to that particular area. So this is a thing which you can say, this is a thing where you are not replicating the things, right? So it is not necessary. In even experimental case with replication is possible, right? But mostly in case of, when I say without replication, this is generally applicable in case of experimental studies. Clear? Now we will understand with and without replication one by one. So I'm explaining firstly for the with replication case. There you need to see the same example I repeated with one more extra independent variable or categorical variable, right? So there you can find we are having the tape strengths. These are the tape strengths given to us. Numbers are the tape strength. These are the various suppliers, and we are having the box type. Means from each supplier we are taking different boxes. You can go and scroll down at the bottom. You can find. So we are having the two different box types. So that means we are having the box type 1. It is coming almost. You can check here. It is coming 15 times, right? Similarly, I'll come to this and you can check type 2 is also replicating 15 times. Means from the type 1 box, 15 different samples I have picked, and these are the strengths I have mentioned here, right? Similarly, from the box 2, the 15 different means from each box one tape is taken, and these are the strengths we have mentioned here one by one. So likewise, you can repeat for the various suppliers, and this way this data was collected, right? Now you need to see, when I talk about with replication, you need to understand how many hypotheses you need to create. Anyone who can guess? Anyone who, how many null hypotheses I need to write here? Any guesses?
2, ma'am.
Sorry?
2 hypothesis, null hypothesis.
2 null hypotheses. Fine. Okay. A good attempt, Sameer sir. Any other idea? Yes? No idea? Fine. Okay. So, friends, we need to create total 3 hypotheses here. 3 null. First one will be, there is no I hope you people are reading.
Yes, ma'am.
Yes, ma'am.
Fine. So this is the second one, the third one. Due to the interaction effect. Done?
Ma'am, what is interaction effect?
That I'll explain. Give me a second. My voice is clear?
Yes, ma'am.
Yeah. This is known as main effect, right? This is also the main effect. And this is the interaction effect, meaning this is only the individual categorical variable you are considering. So that way you are measuring the main effect of one independent variable on the dependent variable. Similarly, in the second hypothesis also, we are considering the second independent variable and we are looking its impact on the dependent variable. But in the third hypothesis, we are combining or considering both the independent variable and simultaneously I want to see whether these two combinedly impacting the dependent variable or not. Right?
Yes, ma'am.
Okay. Clear to everyone? Shall I proceed?
Yes, ma'am. Please proceed.
Yeah.
Ma'am, can you repeat the third once again, please?
Yeah. I said interaction effect. Meaning is I am considering both the things together. Here I want to see when I am taking a tape from a particular supplier and from that supplier if I am picking the tape from the first box.
Mhm.
When I'm combining both the things, so whether there is any difference coming in the strength or not.
All right. Due to both the
Due to
type
both
of
the
supplier.
independent variables combinedly, I want to see its impact on the dependent variable.
All right. Thank you.
Yeah. Now we'll see. First thing I'll show you firstly what you need to provide to perform the two-way ANOVA. So you need to go to the data analysis tab. In the data tab, you will go to the data analysis tools. And there you can find ANOVA two-factor with replication and without replication. Both the cases are mentioned. So we'll go with the with replication test first or case first. So I'm selecting the second option in the box and clicking on OK. So here I'm just showing you this, and firstly I'll go back and I'll tell you the things, and then again I'll come back to the same box. Here you can see what it is asking you. It is asking you to provide the range of your data. Next thing is, which is very important, it is asking you to provide rows per sample. Rows per sample meaning is the variable which you are taking in the row. That is known as the sample variable. So you need to see how many rows per category is coming, right? So in this box type, we are having the two samples, type 1 and type 2, or two groups, type 1 and type 2, right? So initially I showed you, once I selected the type 1, I think it is repeating till here. So the count is coming 15, right? Similarly, when I'm selecting type 2, and you can see the type count is coming 15. So this is a must condition, right? Must condition meaning is what? Whatever the categories you are having, you need to replicate both the categories at what I can say, exactly the same number of times. If the first category is repeating 15 times, second should also be repeated 15 times. If first is repeating suppose 20 times, second should also be repeating 20 times. So this is the main thing which you need to see or consider when you are talking about the two-way ANOVA with replication case, right?
Yes, ma'am.
So I first provide the range of my data. I did so. Now here you need to write, we have seen rows per sample. In each sample, we are having 15 rows. That means if suppose in second box, suppose from the second box only I have taken the 14 samples. Here we are having total 15 samples, but if suppose you have taken only 14 samples, in that case, Excel will not allow you to perform this with replication case. So this is a must condition to perform two-way ANOVA here. Is it clear?
Yes, ma'am.
Fine. Level of significance by default 5%. I'll go with this. Output I'm generating here only. I'll press OK to get output. So I hope everyone has seen what I did. Range will be A2 to D32. Done?
Yes, ma'am.
Yes, ma'am.
Fine. We are getting the output. You can check the output is coming. Now we will read the output one by one. This is the first table, which is the summary table, right? There you can find, this is indicating you according to the type one, means for first box type, right? According to that box type, if I talk about the three suppliers, we are having total 50 tapes from each supplier, right? These are the sum of the strength of the tapes. This is the average or the mean strength of the tapes. This is the variance in the tape. Then similarly for the type 2 box also. So for three suppliers, we have taken total 15 samples from all the three suppliers. These are the sum, average and variances of the tape strength from all the three suppliers, right? In the box 2. Total if I'll do, so combinedly, if I say we are having total 30 samples from each of the suppliers. These are the strengths of tape in the sum form, average form, and in the variance form. Next is the ANOVA table. There you need to see we are having total, means firstly we are having the source of variance. Source of variance means sample, column, and interaction. Sample meaning is the row. Row mein you can find in row what we have taken. We have taken the box type, right? And in column we are having the type of supply. So now you can go and see. If I talk about row meaning box type. So you need to see sum of square for the box type is coming 10. Degrees of freedom is 1. Mean sum of square is 10. F value will be 50.5415 and the P and the critical value. Likewise for the remaining also you can read the table. Now we'll see if I talk about the first, that is the sample case. So up to you if you want to compare these two values that you can do, or if you want to go with the P value that you can do. So if I'll compare the critical and the statistic value, you can find the statistic value is greater than the critical value. So if this will be the case, what will be the interpretation? Anyone? In case of sample? Anyone?
Ma'am, here null hypothesis is rejected, na ma'am? Like
Yes. Very correct. So if I say F statistic is greater than F critical, means you are not accepting your null hypothesis. Similarly, looking at the P value also, you can find your P value is very small than your level of significance. In both the cases, if I talk about, I'll go with that we are going to reject the null hypothesis, right? Done? So this will be for the box type. So I think this is the second hypothesis. This is we are rejecting. Third is, next is the column. Again, you can compare that statistic and F critical. What will be the conclusion? Anyone? Yes?
ma'am, here also F stat is more than F critical.
Means same is the case?
Yes, ma'am.
Right. Third, interaction.
Ma'am, here also we have to reject the hypothesis. F critical is more less than.
Correct. Means in all the three cases, we are rejecting the null hypothesis, right? So we will conclude there is a significant difference in the mean tape strength due to the type of suppliers. Means when you are changing the supplier, so might be possible from each supplier we are getting a different tape strength, mean tape strength, right? So that is the one thing, means supplier is impacting the mean tape strength. Second, again we are rejecting this, so we'll conclude there is a significant difference in the mean tape strength due to type of box. So means when you are considering type 1 box or type 2 box, even then in the both the boxes there is a difference in the mean in the tape strength. So that means it is also impacting, right? And the last thing, when you are considering both, that means from a particular supplier you are taking a particular box, So in that case also you can find that mean tape strength is varying. That means there is a difference is existing in the mean tape strength when you are considering the type of supplier and the type of box both together. So this is the meaning of the two-way ANOVA with replication case. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Shall I proceed to the next?
Yes, ma'am. Kindly proceed to the next one.
Yeah. Next sheet is for your practice purpose that you can use. I'll go to the without replication case. Here you need to read the problem first. So I'll give you few seconds. You please read. I think sheet is with everyone. If it is not visible completely here on my screen, you read at your screen and then tell me what is the meaning of the problem given to you. Done?
Yes, ma'am.
Problem is clear to everyone?
Yes, ma'am.
Anyone can summarize the problem? Yes. Anyone who can summarize?
Ma'am, which formulation of fertilizer is better?
Hmm.
So it is comparing each formulation in 4 different crops.
Very good.
So, yes, ma'am.
Very good. So that means you can find we are having the blends. Three different blends are available. Blend X, Y, and Z. And we are having the four different crops: wheat, corn, soya, and rice. And these are the yields given of these crops. If you are using the blend X on wheat, so this will be the yield or production of the wheat, right? If you are using blend X on corn, so this will be the production of corn. Similarly for soya and rice. And when you are changing from blend X to blend Y, you can find these are the different productions or the yields we are getting for the different crops. Is it clear?
Yes, ma'am.
Now we
Yes, ma'am.
want, yeah, now we want to compare whether the yield of crop is changing when we are considering the type of crop, and when we can say when we are considering the type of blend we are using on a crop. So this is impacting the yield of crop or not. So we need to see whether the type of crop is impacting the yield or whether the type of blend is impacting the yield. This is we need to see. So when we talk about without replication case is only in this case you need to only make the two hypotheses, right? So I'll write the first. Done. Done.
Yes, ma'am.
Fine. So we are now testing these hypotheses using the available data. We'll go to the data type, data analysis, and then using the Box, you need to select the third option, ANOVA two-factor without replication, and click on OK. There, you need to provide the range of your data. Labels is there in my data when I selected the data. Alpha value is 5% and output I'm generating in the same sheet. I think I'm all done, completed for getting the output. What about you? Can I click on OK?
Yes, ma'am.
Done. Now you can see the summary table. This table is talking. We are having the three different blends, X, Y, and Z. Per blend, you can see we are having total four observations. For blend 1, 4. For blend 2, 4. For blend 3, 4. Right? These are the sum of the crops when we are talking about the blend X. Sum of crop for blend Y and Z. Average of the crop means crop in the sense average of the yield of the crop. Right? For all the three blends is listed here. Then variance in the yield of crop for all the three different blends is mentioned here. This is on the basis of blend. On the basis of the type of crop, you can find. We are having, when we will look at the data, you can find for wheat, we are having total three different observations of the yield. Similarly, for the remaining categories. So that way you can find it is coming 3333, right? Then this is the sum of the yield of crop, some average of the yield of crop, and the variance in the yield of crop. So this is the for wheat, similarly for the corn, soya, and rice. Then you will go down and you will get the ANOVA table. There you can see source of variations, rows, columns, and errors is mentioned. Sum of square, degrees of freedom means sum of square f and the further p and the critical value of the f. So you need to see this is your f value for the rows, and means this is your f statistic value and this is the f critical value. So when we are comparing these two or using the p value, if I want to make my inference, so what I can conclude here, anyone?
Reject the null hypothesis, ma'am.
Yes, p is less than 0.05, so we will reject the h naught. What about the second case?
Accept the null hypothesis.
Here your p is greater than 0.05. So here you need to accept the null hypothesis. So that means rows meaning is what? In rows we have taken blend. So blend hypothesis, just a minute, I think I have made a mistake. This is not O, this is type P, right? Similarly, here also it is type. So blend is in the row, right? Blend is in the row. So row meaning is this. This is your row hypothesis. This you are rejecting, right? This is we are rejecting. Right? Because row, for row we are rejecting the null hypothesis, right? And in row we are having blend. In the column, if I talk about, so column 1 I am accepting. So that means in column we are having the crop. So that means first one you need to accept. Right. So we will draw a conclusion here that when we consider the type of blend we are using on the crop, this is making change in the mean yield of the crop. But when we are considering the type of crop for understanding the mean yield of the crop, so that way type of crop is not impacting the mean yield, but the type of blend is impacting the mean yield of the crops. Is it clear?
Yes, ma'am.
Okay. What about others?
Yes.
Yes, ma'am.
Next sheet for you. This is you can help. This will help you to perform the different types of ANOVA. So this way, this is today's session. But if you say I'll take the regression or correlation today, or maybe correlation today and regression tomorrow, as you say. Tell me your capacity. Can I go for correlation today?
Ma'am, correlation, regression take ma'am together, ma'am, in one session only. Better.
Okay. Okay.
So that, we can.
Fine. No issues. Fine. So I'll summarize my session and then I'll take the questions if you are having any, right? So at the conclusion, if I want to conclude this session, I'll say today we discussed firstly the concept of ANOVA. We have seen ANOVA is a kind of parametric test, right? And parametric test, and also it is the extended form of the independent samples t-test. That means in the t-test we can only compare the two unrelated groups. But what if we are having more than two groups and simultaneously we want to compare all three groups together or all the groups together? So in that case, T cannot do that, and we'll go for the ANOVA, especially the one-way or two-way ANOVA we are talking about. So when I talk about one-way ANOVA, actually one-way ANOVA is the real extension of the independent samples t-test, because you can see in both the cases the variable requirement is same. In case of independent samples t-test also, and in case of one-way ANOVA also, the same type of variables we need to have. One dependent, one independent, but in case of independent, we need to have more than two groups available with us, right? Then if I talk about two-way ANOVA, in case of two-way ANOVA, we need to have minimum three, not minimum, we need to have only three variables, one dependent and two independent variables. Dependent will always be your numeric or the continuous variable, and independent will be your categorical variables, right? Then we have seen there are two varieties also inside the two-way ANOVA. That is, we are having the with replication case and without replication case. I told you once you will go for this, what I can say, the data collection kind of thing. So that means generally you will go for the with replication case, right? But as I've shown you one of the example of experimental study, in some cases, in some of the experimental studies, generally we'll go for the without replication case also, right? With replication meaning is what? When you are replicating the categories of your one of the independent variable, right? Which you are taking generally in row. So that is the case of the replication case. But when we talk about without replication case, in that case means when that case dependent, when I say the independent variable, in both the cases you are not replicating the categories of your any of the independent variable. That is a case of without replication. In case of with replications, you need to formulate three hypotheses. One will be first two will be of the main effect, means the single independent variable effect you will see on your dependent variable, and at the third you will club your both the independent variables to see the impact on the dependent variable. In case of the ANOVA, two-way ANOVA with replication, without replication, you need to only formulate two hypotheses. Each means one for the row variable and one for the column variable. Row variable meaning I'm talking row categorical variable and column categorical variable. So for these two variables, you will make two hypotheses, and that way I think performance of the this, what I can say, the t-test, oh sorry, ANOVA test is very easy. That I think I explained you. We have interpreted also the data, and I think now you people are in a position to understand what is the thumb rules of acceptance and rejection of the hypothesis. So I think this is what we have seen today in today's session. Now, if you are having any questions related to your research or something, if you want to ask me, so now platform is open for the same. Yes. No questions. Not possible.
Ma'am, all the things were pretty clear.
Okay.
This was-
Okay. Okay, Samir sir. Thank you. Victoria ma'am has raised the hand. I think. Any question, ma'am? No question? Yeah. No question, ma'am? Fine. What about the rest of the people? Anything you want to ask me? Nothing? No questions?
Thank you, ma'am. There is no doubt that many things are clear.
Okay, fine. So can we call off the meeting for the day?
Yes, ma'am.
Okay, so I'll
Ma'am,
tell you. Yeah,
ma'am,
yeah.
ma'am, when you are explaining, it's fantastic. So when we'll go for practice, then maybe there is a problem will be there. So then I will remember you if
Sorry,
there is
then
an option. I
sorry.
will remember you.
Okay, fine, fine. Okay, I think one thing I want to tell you here at this session. What I explained to you, I think I've taken a very simple examples, but you need to now correlate with your research work, because I think most of you are belonging to the academic side, right? You people are the faculty, right? So fraternity means we all are belonging to the academic fraternity, right? So in that case, if you are using these things in your research, so only you need to see what kind of data you are having, because means what I have understood while taking these sessions, I understood this thing people are lacking, that which test you need to apply on your data, right? So if you are very clear, you want to find the difference, whether you want to find the relationship, whether you want to find the impact of variable on the other variable. So if these things are clear to you, I don't think so you will face any problem in deciding your test, right? Apart from that, if you are very clear with the number of variables you are having, because in each of the sessions I'm trying to emphasize on those that thing, so you need to look your hypothesis at that point of view, at that particular perspective. This will help you to understand in this particular situation which test you can opt. So I think because I think as I am faculty also, so I'm teaching to the students also. So the same complaint I'm getting from them also. So this will come from practice only. If you are collecting your research data, because in most of the researches, I don't know from which field you people are. Some of you are, I think, from the engineering. I think some of you have interacted me yesterday, and maybe some of you are from management side also, right? So usually in management, because I belong to that side, so generally what we are generally studying the human behavior, like attitude we are studying, we want to study the satisfaction, we want to study the loyalty of the customers. Generally these kind of constructs we are studying in the management side, right? So there we will be having a dedicated scale of questionnaire for measuring such thing. So for that, if we are collecting the data, so suppose I am asking 10 questions to understand the satisfaction of my customers, right? So all the 10 questions will be tending towards to the satisfaction, right? So I'll collect the data for the 10 questions along with the demographic data of the respondents, and then I'll take the average. That average of the 10 questions will indicate me the satisfaction score of my customers, and that variable will be becoming for you the dependent variable. Your categorical variables you can take as the independent variable. Using that, you can go for the small tests like t-test, ANOVA, etc. So I think this way, if you will go, I don't think so the research journey will be tough. It will be easy if you are looking from this point of view. I hope I have made clear the thing.
Yes,
Yes.
yes, ma'am. Very fine, very fine, very fine.
Yeah, thank you. So I think I'll try, because I think in most of the workshops which I'm taking on Excel, generally I use this data. But I'll try if in future I'm able to take that data also, means where I'll collect the data using the questionnaire. Or we can do one more thing. I can circulate a small questionnaire with all of you who are starting the sessions. So that way we will be having the first hand data. You will be even aware about the question or statement. So that way, even you will be able to rate the things, right? So that we can do.
Yes,
So I'll
ma'am.
try in the next, yeah, I'll try in the next, what I can say, FDP. I'll try this thing that I'll make a questionnaire and I'll circulate. Means it will be only for the this demo purpose. I will not use this data for my research purpose. To make things clear to the people, suppose there are 50 participants or 40 participants, so you will be able to understand how to collect the data, using the data, how we can work on the data. This is what I'll plan. So this I'll communicate to RFI also, that in the next time we will make certain changes in the what I can say content of the FDP. Right?
Right,
So
ma'am.
hope for meeting again with you. next
Yeah,
time
yeah.
if
Actually,
decided.
sir, I think you will find me very, very frequently on the RFI platforms. RFI is very kind. They are organizing so many of my programs, so they are very kind. So you can find me, right?
Okay,
I think simultaneously two programs are going on right now. That is why this program is getting delayed, because I am taking 5:30 to 7. I am taking the other program.
okay, ma'am.
Yeah. Okay, so I think this is all from my side. If you're not having any query, we can wind up the meeting for the day. We will be meeting tomorrow for the last session. There I'll firstly talk about the correlation. I'll talk about the regression. Then I'll take few situations where this can help you to understand in these situations which type of test you can apply. Fine, everyone.
Okay, thank you, ma'am.
Yes, ma'am. Good night, ma'am.
Yes,
Yeah.
ma'am. Thank you.
Thank you. Thank you, everyone.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you. Fine. So I think we are done. Good night. Yeah, take care. Good night, everyone. We are meeting tomorrow for the last session. Over to you, Yogra sir. We are done for the day. Thank you, sir. Thank you, everyone.